In the past videos, we've been talking about internal energy, in which we added, for instance, energy to the system by work or by heat. And that energy went into either rotation or vibration or kinetic. And in that case, we noticed that when we added energy, the temperature rose. However, there is another place that energy might be able to be used. We talked about the fact that the amount of energy required depends on the degree of freedom. So if there are changing numbers of ways that the energy can be divided, one can add energy and be added to more bank accounts, if you would, rather than rising the amount of any one bank. So think of this way. If you had $3 and you only had one bank account and you put all $3 in that, then you have a height of 3. And you get $6 more. Now, if you don't change the number of bank accounts and you put it in, your number goes to 9. That's like your temperature going up. But if at the same time you get the $6 extra, you had 2 more different types of bank account. Maybe one was a CD, maybe one was a savings. Then each one of them could also get $3. So your total amount of money had gone up to 9, but it's split 3 ways. Since the amount in any one bank account didn't go up, that's like the temperature. Even though you got more internal energy, your temperature did not rise because you had more ways to spread this around. This occurs when bonds are made or broke. And when this happens, you get what is called a phase change. So in this discussion, we're talking about phase change in bonds. So we've been putting energy in and we've been heating it, and according to specific heat, we've been raising the temperature. But there can come a time when either we add energy or take energy out of a system. And for instance, there could be these molecules moving by, and if they're moving with a lot of kinetic energy, they just go by and they never really get a chance to stay near each other long enough to bond. But if we take energy out of the system, this atom here and this atom here coming close will get close enough that they can actually stick together. And we can end up with what amounts to basically a harmonic oscillator. So before, there were only translational ways to store energy. Now we have new bank accounts due to vibrational men. And they don't have to just be 2 of them. There can be many different configurations. So that means that although we added energy, some of that energy is going to create these bonds and not raise the temperature. Or another way of looking at it, the energy is going into more different bank accounts. So the degrees of freedom is going up. The total energy inside is going up, but the energy per molecule per degree of freedom is not going up. Now, another way to look at this is, here is a potential energy curve for this particular interaction. And if you had energy up here, you have more energy and you're out of the well. But if your energy was dropped, that is, if you gave away some of your energy, you could get trapped. But energy would have to be given away. And that missing energy then is given off to the environment. So another way this happens is that these guys come together, form, and energy can be released. This occurs when you get an exothermic reaction, when 2 chemicals come together and they combine and they give off energy. In order to then break those bonds, one would actually have to give energy to this system to break the bond. So making of bonds can give off energy, breaking of bonds can require energy, and neither one of these would allow a change in temperature till all the bonds were made or all the bonds were broken. These are phase changes. So the creation of chemical bonds making of springs can release energy, and the breaking of chemical bonds destroying springs requires energy. I don't know why I said requires and takes. One of them is good enough. This is called a phase change. Now, it depends on how much energy is required to make a bond or break a bond and how many bonds you have to make. So, this leads us to what's called the latent heats. The latent heat is the amount of heat required by 1 unit of mass of a substance to change all of its particular bonds. And until all those bonds are changed, you can't be using that energy for anything else. The way we write this is the energy that we're going to provide in the form of heat is going to go into the latent heat times m, where m is the mass. So this is the mass, and this is the latent heat. So the latent heat is related to the energy required to make or break so many bonds in 1 kilogram of mass. The more mass, the more bonds you got to make, the more energy it's going to take to make those bonds. Likewise, if you're creating bonds that give off energy, then the more energy it gives, the more bonds you make, the more energy you can give off. So you got steam coming in, making bonds to become water, then it can release energy. If you've got water that has bonds and you've got to break those bonds to make free particles, it takes energy to convert it to steam. And this energy occurs without the rise of temperature. When you vaporize, that is when you break liquid bonds in order to make a gas, we call this the heat of vaporization, or the latent heat of vaporization. And generally we're talking about water, and for water that amount is 2.26 megajoules for 1 kilogram of water, or 540 calories for a gram of water. This is the amount of energy required to break all of the water bonds in 1 kilogram of water. It takes 2.26 megajoules. If you're converting from steam back to water, then you will release 2.26 megajoules for each kilogram of water you produce. Likewise, if you're talking about from a solid to a liquid, you get what's called the heat of fusion. This is the quantity of heat required to melt 1 unit of mass, that is to break the ice bonds so that you only have liquid bonds. The amount is 335 kilojoules to convert 1 kilogram of ice into water, or 80 cals per gram. You will see that it takes less energy to convert from ice to water than it does to convert water to steam. Steam has a lot of energy. This is why steam can burn you really bad. Heat of sublimation. It is also possible to go directly from a solid to a gas. If you do that, it's called sublimation. This can only occur at certain specific temperatures and pressure. In each case, what you do is find out how much it takes to break 1 kilogram of bonds, multiply by the number of kilograms, which is basically saying find out how much it takes to break a bond and multiply by the number of bonds, and then that's the amount of energy that you either have to give it, or if it's releasing energy making bonds, that's the amount of energy it will give to you. And during that time there will be no temperature change. None. Okay? So you can give heat and see a temperature change as you give heat, but then you can give heat and not have a temperature change, and this is a phase change. And then you might, again, after you've converted everything, start with potentially a different slope because it might have a different specific heat. But again, as you give more thermal energy to the system, as you heat it, you'll have a temperature change again. Phase changes involve giving energy or releasing energy with no temperature change. All right, that is all there is for this video.